Okay, we're going to write an equation in slope-intercept form, but we're not actually given the slope, and we're not actually given the intercept either. So here's the method to do it, and this will be a little bit more of a challenging problem than some of the other ones, but we're going to start out with something that you know, which is the equation for the slope is y2 minus y1 over x2 minus x1. So let's identify what is um, y2, y1, x2, x1. So let's call this point number 1. If this is point number 1, then this is the x-coordinate of point number 1 and the y-coordinate of point number 1. If this is point number 2, and it doesn't matter which one you choose for point number 1 and which you choose for point number 2, it's still going to work out to be the exact same number no matter what. Okay, so we can say, okay, then the slope will be y2, negative 1, minus y1, 4, over x2, 3, minus x1, negative 2. And when we resolve that, we get for the number on top, negative 1 minus 4 is negative 5. And on the bottom, we get 3 minus negative 2, which is the same as 3 plus 2, which is 5. And when we simplify that, we get negative 1. So we've got a slope of negative 1. So that's a piece of information we're going to need. So if we write the equation, then watch what we can do. This is kind of a cool trick, and you'll hopefully appreciate this. We say if the equation is y equals mx plus b, and we know that m is negative 1, then we've got really y equals negative 1x or negative x plus b. It doesn't look like it, but we actually we put the slope in there. Here's the slope where we put that negative 1 in there. Okay, so you don't see m anymore because slope is written as a number, the number negative 1. Now, how do we find out what b is? We don't have a graph. We don't have any other more convenient way to do it. This is what we're going to do. We're going to take one of the points, either one of them, and we're going to substitute in the y and the x values, because then we'll be left with just a single variable remaining that we don't know. And in that case, it will be b, and then we can solve for it. So I'm going to write in, I'm going to pick, for no good reason, I'm going to pick the first one that we've got up here, negative 2 comma 4. Y is 4, and the x is negative 2. Okay, so now I'm going to start to simplify this equation to find out what b is. Well, this is just 4 equals a negative of negative 2 is positive 2. So I got 2 plus b. And to solve for b, then I just subtract 2 from both sides, and I get 2 is what b is equal to. And so I can then write the equation y equals negative 1x, or just negative x, plus the b value, which I might as well mark down here, of 2. Okay, so that's our equation. And if you wanted to, you could just check by saying, okay, if that was our equation, then what if I plugged in the other points? So I'll do this over here for you. Do it in green. I'm running out of space, sorry, but if we said the equation is y equals negative x plus 2, then we should be able to plug in point number 2's values. Y is negative 1 right there. And plug in the x value of 3, complete the rest of the equation, and then simplify it. Negative 1 is equal to negative 3 plus 2, or negative 1 equals negative 1. Check. We did a proof of it. We said, okay, if we used this point to find b, and we did, once we found the slope by using this, we found the slope, which is this. We wrote part of the equation, y equals negative x plus b, and then used the first point's coordinates for y and for x to plug them in and get rid of the two variables y and x. By getting rid of them, what I mean is we're using actual numbers, so there's only one missing value. And When we simplify that, we find b. So we used point number 1 to find b and therefore write the equation. So now we're going to use point number 2's x and y values just to check that our equation was correct. Because if it was correct, then it should work for that point 2. And it does. Works for that point 2. So we're done.